Hello, my name is Ruth Mutson, and I'm a Community Involvement Coordinator for the U.S. Environmental Protection Agency. I'd like to welcome you to this virtual public meeting regarding EPA's proposed cleanup plan for the Petoskey Manufacturing Company, or PMC, Groundwater Superfund Site. If you've been to other EPA public meetings, you can see that we've adjusted our meeting format to help ensure public safety during the ongoing COVID-19 health crisis. We hope that you find this presentation and our outreach methods helpful and informative. This virtual meeting will provide some background information on the PMC groundwater site and the work conducted by EPA. We will also provide you with details about the investigation conducted at the site and EPA's proposed cleanup plan. EPA issued a document called an Interim Action Proposed Plan to describe the proposed cleanup plan and gather the public's comments and questions about the plan. After a 30-day public comment period, EPA will provide responses to public questions and comments in a decision document called an Interim Record of Decision, or ROD. There are many ways you can submit your questions or comments to EPA. First, you can submit a comment directly at www.epa.gov/superfund/PMC-groundwater. You can also find the Interim Action Proposed Plan on this website. Next, you can leave a confidential voicemail at 312-353-4872. Or you can email me at mutson.ruth@epa.gov or Cheryl Condrick, the Remedial Project Manager, at condrick.cheryl@epa.gov. Finally, you can mail your written or typed comments to Cheryl Condrick at the U.S. EPA, 77 West Jackson Boulevard, 6th floor, Chicago, Illinois, 60604. We understand that you may have questions regarding the proposed cleanup plan after watching this presentation. We invite you to join EPA representatives during a virtual meeting on June 29th at 6 p.m. Eastern Time. A Zoom link to the meeting and dial-in instructions will be posted at www.epa.gov/superfund/PMC-groundwater the day of the meeting. I will now hand the presentation over to the EPA Project Manager, Cheryl Condrick, to explain the proposed cleanup plan and provide background information on the PMC groundwater site.
Hi, thank you for the introduction, Ruth. Over the next few slides, I will go over some background and history of the PMC groundwater site, describe the investigation activities conducted to date, and discuss EPA's proposed plan to address contamination at the site. The PMC Groundwater Superfund Site is located along the Little Traverse Bay and approximately 500 feet west of Bear Creek. The study area for the supplemental remedial investigation is shown in blue. The former PMC facility is shown in the yellow box and is also referred to as the source area. This area was redeveloped into the Water Street condominiums. The site was listed on the National Priorities List, or NPL, in 1983 because a municipal supply water well was contaminated with volatile organic compounds, or VOCs. The main contaminant of concern is trichloroethylene, or TCE. A Record of Decision, or ROD, was issued for the site in 1998. EPA's cleanup plan included excavation and off-site disposal of contaminated soils and soil vapor extraction to treat deeper soil contamination in a small portion of the site. Groundwater contamination was addressed with monitored natural attenuation, or M&A. M&A involves allowing natural processes, such as evaporation or dilution, to decrease or attenuate the remaining contaminants in the groundwater. Institutional controls in the form of a deed restriction was placed on the former PMC property to restrict access to the soils left in place and the groundwater. Additionally, the City of Petoskey has an ordinance that restricts the use of private potable wells. In 2000, the Potentially Responsible Party, or PRP, declared bankruptcy. Since then, EPA has been funding investigations and cleanup at the site. Additional information on the work conducted under the 1998 ROD is available on the PMC Superfund website. VOCs like the ones at the PMC site can evaporate from contaminated soils and groundwater. As shown in this diagram, the contaminated soil vapors move up from the contaminated groundwater and soils and can accumulate underneath buildings. These vapors can then enter buildings through cracks in the foundation, cracks in basement floor or walls, and utility lines. This process is known as vapor intrusion. The 2014 5-year review of the site identified an inhalation exposure pathway. In 2016, EPA began investigating the vapor intrusion pathway within the study area at the PMC site. From October 2016 through November 2018, groundwater, soil, and soil vapor samples were collected to define the nature and extent of contamination at the site. The data shows that the groundwater plume extends to the north-northwest from the source area. The maximum contaminant level, or MCL, is the maximum allowable limit of a contaminant in drinking water. EPA's MCL for TCE is 5 micrograms per liter. The maximum concentration of TCE in groundwater was 36 micrograms per liter at the source area. The soil vapor plume extends from the source area to the west-northwest. The maximum TCE concentration of 15,000 micrograms per cubic meter was detected at the source area. For comparison purposes, the default EPA vapor intrusion screening level for soil vapor in a residential setting is 16 micrograms per cubic meter. Soil samples were also collected at the source area. However, due to the subsurface materials and drilling method, the results underrepresent the true soil concentration at the site. The maximum TCE concentration was 1,100 parts per billion, or ppb, above the water table, and 2,700 ppb below the water table. These soil concentrations were from samples collected in the western half of the source area. This slide shows the extent of TCE contamination in the groundwater. The call-out boxes list the sample location name, then the depth below ground surface that the samples were collected, and the concentration of TCE in groundwater at that location. The blue outline shows groundwater contamination up to 5 micrograms per liter, which is the MCL. The green line is the limit of detection. We have seen that the groundwater generally flows to the lake, but at a very slow rate. We have also observed that the groundwater flow direction can shift from the lake inland, depending on the elevation of the lake's water level. This map shows the locations where soil vapor wells were installed and the corresponding TCE soil vapor results. When field conditions allowed, soil vapor samples were collected from 3 depths at approximately 5, 10, and 15 feet below ground surface. 2 rounds of soil vapor samples were collected. This data shows that at the source area, the soil vapor concentrations decrease with depth, indicating soil contamination as the main source of contamination. Outside the source area, the soil vapor concentrations increase with depth, showing that contaminated groundwater is the main source. This is important to understand when implementing the remedy or cleanup at the site. This map shows locations where soil samples were collected. The call-out box lists the sample location, the depth below ground surface from which the soil sample was collected, and the TCE concentrations in ppb. This figure shows the most detected and higher concentrations of TCE in soil are located on the western half of the former PMC property. EPA also conducted vapor intrusion investigations at 25 properties in the study area, 2 of which were multi-unit properties. Multiple rounds of subslab soil vapor samples, outdoor near-slab soil vapor samples, crawl space, and indoor air samples were collected from these properties. EPA's Emergency Response Branch mobilized to the site in 2017 due to unacceptable levels of TCE in indoor air. To address the indoor air exposure, EPA installed vapor intrusion mitigation systems on 2 properties, including the condominium units located at the source area. A mitigation system was installed in each individual condo unit. This system, as shown on this slide, draws the vapors from beneath the building through an inline fan and vents it above the roofline. Samples were collected after the installation of the systems, which demonstrated that the TCE was removed from the indoor air by the system. EPA continues to seek access agreements to sample additional buildings in the study area to ensure vapor intrusion is not occurring. Vapor intrusion is very building specific and can present different concentrations seasonally. Therefore, multiple rounds of sampling are conducted to ensure safety of the building occupants. EPA asks for the community's cooperation and access to your property as we continue to obtain information on specific buildings. EPA used the collected data to create what is called a conceptual site model, or CSM. This tells the story of the contamination at the site, how the contamination is traveling, and how people may be exposed to the contamination. Beneath the Water Street condominium's property to the right of the diagram is the soil and groundwater contamination that still exists at the site, and shown in red. This contamination from the ground surface moved down into the groundwater located below the blue line, which represents the groundwater table. The contamination was drawn deeper into the subsurface limestone materials and toward the lake when the Ingalls well was in use, and is shown here as a pink plume. Once the Ingalls well stopped pumping, the natural groundwater flow returned, which we found to be flowing both toward and away from the lake at different times, depending on the influence of the lake levels. You can see purple arrows near the top of the water table and from the source area, showing the movement of the contaminated vapors, evaporating and moving upward. Buildings located above these arrows are susceptible to vapor intrusion. As mentioned before, a complete vapor intrusion pathway was found at the source area and one building off-site where vapor intrusion mitigation systems were installed. This diagram is conceptual and does not show all locations where vapor intrusion may be occurring. Also, even though there are some soil removal that was conducted at the source area during implementation of the 1998 ROD, a significant amount of contamination under the building was left in place. Also shown in this diagram are the various subsurface materials. There's limestone bedrock at the bottom of the diagram shown in gray blocks, friable limestone with sand and gravel above that shown in the yellowish blocks, and under the source area there are additional various layers of gravelly silt and clay, broken up limestone with sand and gravel, and even cobble-sized stones that were found when drilling in the area. So what are the risks from this contamination? The information collected during the supplemental remedial investigation was used to determine the human health risks and presented in a Human Health Risk Assessment, or HHRA. The HHRA identified TCE as the contaminant of concern, or COC, at the site, which was the biggest contributor to human health risks. EPA looks at cancer and non-cancer risks associated with contaminants and how people would be exposed to the contaminant. This HHRA focused on the inhalation pathway because the risks associated with possible ingestion and direct contact of the contamination was previously addressed in the 1998 ROD. EPA defines unacceptable risk as increased cancer risk more than 1 in 100,000 or non-cancer hazard index greater than 1. The HHRA is available in the 2019 Remedial Investigation Report. EPA looked at various possible scenarios of people being exposed to the vapors and found unacceptable non-cancer hazards greater than 1 for future risk associated with subslab soil vapor exposure via volatilization to indoor air, in other words, vapor intrusion, to residents via inhalation. Michigan Department of Environment, Great Lakes, and Energy also identified 3 potential COCs, benzene, ethylbenzene, and tetrachloroethylene, or PCE. EPA will monitor these compounds along with TCE throughout the cleanup process. Finally, there were no ecological risks identified at the site. To address the risks identified in the HHRA, EPA selects a remedy to clean up or otherwise prevent unacceptable exposures to contamination at the site. The scope of this interim remedial action will address the contamination at the source area and focus on the vapor intrusion pathway by remediating the source of soil vapor contamination, which are the soils and groundwater beneath the former PMC property. Additionally, EPA will install vapor intrusion mitigation systems outside of the source area at specific buildings where there may be a future vapor intrusion risk. This cleanup effort is an interim action because it only addresses the source of vapor intrusion at the former PMC property. The cleanup of the downgradient groundwater plume will be assessed and finalized after we implement this interim action. This interim remedial action has 2 main remedial action objectives. 1. Reduce the mass of TCE and other potential COCs in soil and groundwater under the former PMC property that acts as an ongoing source for exposure via inhalation until contaminant mass can no longer be recovered, or until soil vapor, groundwater, and indoor air all reach the preliminary remediation goals. 2. Mitigate vapor in buildings from vapor intrusion within the study area that pose an unacceptable current and future risk to human health via inhalation. In order to achieve these objectives, EPA evaluated 3 alternatives for cleanup at the site. No action. This alternative is included at all cleanups for Superfund sites to serve as a baseline to compare the other alternatives to. Air sparge with soil vapor extraction, or ASSVE, and in situ chemical oxidation with soil vapor extraction, or Isco Sve. Both of these alternatives would treat the contamination in place. There are some common elements that will be implemented with any selected remedy, except for the no action alternative. These common elements are installation and maintenance of mitigation systems outside of the treatment area, vapor intrusion monitoring of properties surrounding the treatment area, whether they have mitigation systems or not, a pre-designed investigation to refine the source area and provide specific design information as necessary. This investigation is anticipated to include soil vapor, and groundwater sampling, monitoring well installation, sampling, and analysis. Institutional and engineering controls, such as signs and fencing, will be necessary to ensure public safety during construction and, if applicable, operation of the remedy. And the common elements also include 5 years of monitoring after the system is shut down. In addition to the common elements previously detailed, the ASSVE alternative includes air sparging, a commonly used technology to treat VOCs in water. With air sparging, air is injected into the subsurface through wells installed in the contaminated groundwater. The injected air helps evaporate the contamination from the groundwater into the vapor phase. The vapors are then captured by the Soil Vapor Extraction System, or SVE system, from wells installed into the soils above the groundwater. The SVE system would also pull contamination from the soils that exist underneath the buildings. The vapors are then treated through a carbon filter. The spent filter is disposed of off-site. Both the AS and SVE wells will be drilled horizontally underneath the existing condominium buildings and beneath any existing utility lines. EPA is proposing to use a segmented well system such as the vertebrae well system, which would target and isolate the highest contamination beneath the buildings. The current conceptual design is to have 3 horizontal air sparge wells, 3 to 6 inches in diameter, with a total of 18 segmented wells within the 3 boreholes. These would be installed at approximately 30 feet below ground surface. EPA is proposing installation of 4 SVE wells, 4 to 7 inches in diameter, with a total of 22 segmented wells within the 4 boreholes. These would be installed at approximately 10 feet below ground surface. The feasibility study expected the system to run for 5 years to achieve our objectives for the site. The cost to implement this remedy is estimated at $5.5 million. The Isco Sve Alternative is similar to the AS-SVE, except the groundwater would be remediated by injecting oxidants into the groundwater to destroy the contaminants. Any vapors released from the process would be captured by the SVE system. The SVE system would also pull contamination from the soils that exist underneath the buildings. The vapors are then treated through a carbon filter and the spent filter is disposed of off-site. Both the ISCO and SVE wells will be drilled horizontally beneath the existing condominium buildings and beneath any existing utility lines. As previously described, the wells will include the segmented well system, and conceptually, the well configurations for the ISCO and air sparge will be the same with 3 horizontal wells installed at approximately 20 feet below ground surface. The SVE system installed would be the same as described for the AS-SVE system. In treating the groundwater with ISCO, the oxidants must have direct contact with the contaminated groundwater. Therefore, the effectiveness of moving the contaminant depends on the groundwater flow or movement at the site. Because the groundwater at the PMC site doesn't naturally flow very much, additional engineering such as recirculation wells or extraction wells would be needed to move the oxidants through the contaminated groundwater. Based on the concentration of TCE in groundwater at the source area, it is estimated in the feasibility study that 3 separate injection applications would be necessary to achieve our objectives. The SVE system would continue to run for 5 years to achieve objectives. The cost to implement this remedy is estimated at $5.2 million. This map shows the proposed system layout and configuration for the air sparge and ISCO wells. The light blue line shows the location of the 3 horizontal wells. The black dashed lines within the blue line represents the individual well segments within each well. The laydown area in yellow represents the area from which the drilling would begin in the Bayfront Park parking lot. The purple box is the location of the proposed system components building. This building would house all the electrical, piping, and filters needed to run the system. This map shows the SVE well configurations. Again, the light blue lines represent the 4 SVE wells. The black dashed lines represent the segmented wells within each horizontal well. The SVE system components would be housed in the same building as the air Sparge Isco, shown in the purple box, and the laydown area is proposed in the Fraternal Order of Eagles parking lot if access is granted. Here is a simplified model of the segmented well system. The larger borehole will house multiple separate well screens separated by grout. Each segmented well will have piping to the surface where air or oxidant can be injected or air removed for the SVE wells. How does EPA choose a preferred remedy to meet our objectives for the site? By law, EPA is required to assess each remedial alternative against 9 evaluation criteria. Overall protection of human health and the environment, compliance with applicable or relevant laws and regulations, long-term effectiveness and permanence, reduction of toxicity, mobility, or volume through treatment, short-term effectiveness, implementability, cost, state agency acceptance, and community acceptance. The last 2 criteria are evaluated after the public comment period ends. With these criteria in mind, EPA's recommended remedy to address risk and contamination at the site is the air Sparge with soil vapor extraction. Both alternatives presented are equally ranked for most of the criteria. There is just a slight disadvantage to using Isco because of the lack of natural groundwater flow at the site. Once the remedial action objectives for this interim action are met, EPA will assess the state of the source area and down gradient plume to determine what, if any, additional remediation will be necessary and issue a final ROD for the site. EPA is looking for comments from the public on the proposed plan. The public comment period opened on June 22nd and will run for 30 days until July 22nd. EPA will address the public comments in a responsiveness summary that will be included in the interim record of decision. EPA aims to have a signed ROD by the end of September 2022 and to begin the remedial design at the end of 2023. With that, this concludes the technical portion of our presentation, and I will now hand the presentation back to Ruth.
Thank you for participating in this virtual public meeting. As mentioned at the beginning of the presentation, there are multiple ways to submit your public comments on this proposed cleanup plan. First, you can submit a comment directly at www.epa.gov/superfund/PMC-groundwater. Next, you can leave a confidential voicemail at 312-353-4872. You can also email me at mutson.ruth@epa.gov or cheryl@condrick.cheryl@epa.gov. You can also mail your written or typed statement to Cheryl Condrick at the U.S. EPA, 77 West Jackson Boulevard, 6th floor, Chicago, Illinois, 60604. And of course, if you have any questions or need assistance with submitting a comment, you can contact myself or Cheryl Condrick. Thanks again.